Today we're on our second day of simplifying radicals. I put all the rules up again. So there they are. Let's go over them. A radical is simplified if there are no perfect squares, there are no fractions in the square root symbol, and there are no radicals in the denominator. So there's a couple ways to go at these first. The first thing I always do is I like to see if you can simplify what's under the radical. So the first way you can do this is to simplify first. So we can see that 20 divided by 4 is 5. So then we would have the square root of 5. If you look at the square root of 5, there are no perfect square factors of 5. So we're done. Okay, so if you want to go about this a different way, we can break each of the numerator and denominator down. So we can take the square root of 20 over the square root of 4, right? So the square root of 20, there's a perfect square factor, so we can take that, the square root of 4 times the square root of 5 over the square root of 4, and these cancel each other out, so you get to the same place, the square root of 5. Okay, so number 2, it's just my preference, but I like to look and see if you can simplify first. So 35 divided by 5 is the square root of 7. There are no perfect square factors of 7, so we're and that's the beauty of simplifying first. But if not, you can take this and break it down to the square root of 7 times the square root of 5 over the square root of 5. We can cancel those square root of 5s out, so we end in the same place, the square root of 7. Either way works. Okay, so if we want to go my simplifying route first for number 3, I'm going to take 50 divided by 2, which would leave me with the square root of 25, and the square root of 25 is 5. If you want to do it this way, I'm going to break down the square root of 50 into the square root of 25 times the square root of 2 over the square root of 2. Those cancel. I'm left with the square root of 25, which again leads us to the same place, which is 5. Okay? So number 4, I would definitely simplify first. So I'm going to take that 45 divided by 5, which will give us the square root of 9 over x to the 4th. So then we have the square root of 9 over the square root of x to the 4th. Remember, we're looking for pairs. So x to the 4th looks like that. And we have 2 pairs. So you're going to take 1 for every pair. So we are left with x squared on the denominator. The square root of x to the 4th is x squared. And the square root of 9 is 3. So we are left with 3 over x squared. Okay, so this next one, we have the square root of 2/5 over the square root of 6/5. Because those denominators are alike, I'm just going to multiply across. So I have the square root of 12 over 25. If we break this down, it's the square root of 12 over the square root of 25. We can break down the square root of 12 to the square root of 4 times the square root of 3. And the square root of 25 is 5. So now the square root of 4 is 2, so that comes to the outside of the radical. So we have 2 root 3 over 5. We can't simplify any farther, so we're done. The square root of 2/5 is another thing altogether. You know, our rule here says that you cannot have a square root symbol in the denominator. There are no perfect square factors in 2/5, so I'm going to show you another way to get rid of that square root symbol. It's called rationalizing. What I'm going to do is I'm going to take this and I'm going to multiply it, both the numerator and the denominator, by the square root of 5. If you take the square root of 5 times the square root of 5, you have the square root of 25, which is a perfect square. So in essence, multiplying that by the same thing is going to get rid of the square root symbol, right? So I'm left with 5 here, and then square root of 2 times the square root of 5 is the square root of 10. No perfect square factors in there, so we're done. A couple more here. The square root of 9/7. I'm going to rationalize that by multiplying both the numerator and the denominator by the square root of 7. Multiplying that gets rid of the square root sign in the denominator, and now I have the square root of 63. You can break that down farther to the square root of 9 times the square root of 7 over 7. The square root of 9 is 3. There are no perfect square factors in the square root of 7, so there's my answer. You cannot cancel these because the square root of 7 is not the same thing as 7, so you can't cancel that direction. All right, the next one. You don't want to ever forget that that 3 is sticking out there because no matter everything that you pull out is going to be multiplied times that 3. So let's do this. There are some perfect square factors, and before I get multiplying by the square root of the denominator and get a number that's too big for me to handle, let's break this down a bit. So I have 3 times the square root of 4 times the square root of 3 over square root of 4 times the square root of 2. So what I did is I broke down the 12 and the 8 into perfect square factors, and I'm going to cancel this. I have 3 times the square root of 3 over square root of 2. I'm going to rationalize by multiplying times the square root of 2. So now I have 3 root 6 over 2. That's my final answer because there are no more perfect square factors of 6. Number 9. No perfect square factors. I guess I could pull the x out, but I'm going to wait. So I'm going to multiply this by the square root of 6. I'm going to rationalize that. So I have the square root of 6x to the 7th over 6. Now that x to the 7th is really 3 pairs and an oddball. So I'm going to pull out 1, 2, 3, x cubed, and leave 1 inside. So I have x cubed root 6 over 6. No perfect square factors of 6. Can't cancel this way, so I am done. All right, this next one, I guess you can go at this a couple different ways too. First, I'm going to multiply what's on the outside. 2 times a half. 2 halves is 1. I'll just put that out there for grins. Now I'm going to multiply 2/3 times 18, which will give me the square root of 36/3. I'm a big fan of simplifying, so 36 divided by 3 is 12, so I have 1 times the square root of 12, which I'm going to break down into the square root of 4 times the square root of 3, so that gives me 2 root 3. Okay, 11. Here's how I would go about this one. We know that when you divide variables, you are subtracting the exponents. So I'm going to simplify this first. So if I'm dividing x to the 7th by x to the 1st, I'm going to subtract. So I have the square root of x to the 6th. And if I'm dividing y to the 10th by y to the 4th, I'm going to subtract and I'm going to have y to the 6th. Now I have 3 separate pairs. So my square root of x to the 6th is x to the 3rd, and y to the 6th is y to the 3rd. Let me just finish up here. Y to the 3rd. Okay, we're going to do the next page tomorrow. Look for your homework. Your homework will be just like these notes. If you have any questions, don't hesitate to email me. Take care of yourselves. Talk to you soon.